like any business, automobile repair has its own special problems. And like any business, automobile repair has its headaches. But one great blessing it has over other careers. Only one thing is required to go straight to the top, whether it's in a large shop or a small garage. That's knowing how to fix that car and fix it well. And where the mechanic knows major engine repair, a stream of cars will beat a path to his shop, no matter where he's located or how he parts his hair. Working for him are two powerful factors. One, the world's automobile population is exploding like the human population. Yet we are only producing a small increase in the number of really skilled career-type master mechanics, ones capable of handling major work. This means the advanced mechanic or garage owner who devotes a little time to regular study and brush-up finds himself in an increasingly favorable position. At the heart of major engine repair lies the science of bearing replacement, which reaches into all systems of the engine. Therefore, many engine repairs either begin or end with bearings. Bearing replacement is easy if you give it a little study and a lot of care. The bearing must take the full power impulse of the engine and save the expensive shaft. It's subjected to unbelievable destructive power, and it's got to take it without failure. Because when bearing failure does occur, the customer's got big problems, and sometimes so does the mechanic. One customer knows all about it and is ready and willing to tell us which half of which bearing has failed. Another, not always a woman, thinks her engine knocking needs only a couple of turns of a screwdriver, and that a bearing is something a sea captain takes with his compass. But the experienced mechanic thinks of worn bearings when he sees and hears three things: engine knock, excessive oil consumption indicated by smoke or the customer's story, or low oil pressure. Once you confirm that the bearings are worn, the problem is not to merely replace them. We'll get to that later. First, find out what caused the wear and correct that. Repeat, find out what caused the wear and correct that. A little selling involved, because if our customer needs bearings, he wants to buy bearings only. He doesn't know that a failed bearing is only a clue that something else is wrong. Nor does he know that our first job is a detective job. And one of our suspects is himself and his driving habits. Another is the character and work habits of the last mechanic to work on the car. But neither are too hard to track down. They leave very explicit fingerprints on the bearings themselves. Your first move is to read these prints. Now, complete bearing failure destroys the fingerprints and won't reveal its story. But adjacent bearings may provide the clue to the cause of failure of this bearing. For example, this bearing surface reports fatigue and overloading. It happens this way. Extreme operating loads and heat, often caused by unwise driving habits such as lugging, crack the bearing metal very minutely. As heat and loads continue, the cracks drive for the bond line. With more loads, more heat, the cracks change direction, just this side of the bond line. The small particles of bearing material which now flake off crowd the shaft, overheat, melt. Disintegration begins. Take another look at the culprit, or rather this one. About all you can do to correct this is explain overloading to him and be sure his engine is repaired with high-duty bearings. Next set of fingerprints. This one tells of foreign particles on the bearing surface. You can see and feel them. Now, the bearing is designed to absorb a certain number of small particles so they won't score the expensive crankshaft. But when a great many small particles build up within the bearing metal, or particles too large for absorption find their way into the oil clearance, trouble occurs. Under load, when the oil clearance normally becomes smaller, the bearing with the embedded dirt particles becomes a grinding wheel, grinding down the crankshaft. But what do you do to correct this? Well, see if the owner is changing oil and oil filters regularly. The oil is meant to carry off foreign particles. See also that the air filter is cleaned regularly, properly seated, connected, and working properly. That in the future, the owner uses a careful, competent mechanic. Because those foreign particles could have been left there by the man who ground the valves or honed the cylinder. Scraps of hard steel or burrs. The fight against dirt and metal shavings in the close tolerance parts of the engine is half the battle. Next case. What do these three tell you? Well, this time the culprit is not the owner. All three tell you about a mechanic. Each time, he made the same mistake in three different ways. Improper seating of the bearing. Take this first one. Notice the place where the babbitt surface has actually flaked off? Now let's take a look at the back. See that spot? That means a piece of dirt between the back of the bearing and the seat. You lose your roundness of bearing seat. And looking at it the other way, obviously it's going to pinch the shaft, wear in one spot on the bearing, overheat in one spot, melt. Now the second bearing tells a different story. If we turn it over, you'll notice it's very shiny on the back. Why? Because it's been moving within its bore. Why did it move? Here's our answer and the culprit. During installation, the mechanic saw the bearing projecting above the bearing cap. Thinking to make a better fit, he filed down the parting faces. Fits easier now, but it throws away the whole advantage of bearing crush and makes a loose fit. The bearing can spin in its bore. That projection was designed for a tight fit when the bearing is assembled. Next, the bearing at the top. These fingerprints point to filed bearing caps. That mechanic loves the file. He wanted less oil clearance this time, so he took out his trusty file and effect, too much crush. Result, side pinch. And you can see where the bearing wear will occur. Never file bearing caps. Next case. Now here are two halves of the same bearing. Notice how they're worn on opposite sides? Let's take a few seconds to guess what problem this type of wear points to. Connecting rod misalignment. A bent or twisted rod does this. you can see the bearing has no chance. The same effect would result if the bearing caps had shifted, which happens if too large a socket is used to tighten the bearing caps, so that it crowds against the cap, causing a shift. Next, what caused this type of wear? Let's take another guess. Well, the correct answer is out-of-round bearing seat. Obviously, any new bearing will also quickly conform to this out-of-round seat, creating metal-to-metal contact and terrific wear in the area of the parting line. So you see, we've stolen the man's money, unless we first correct the bearing seat. All right, next one. The fingerprints on this bearing, you won't always be able to trace. Hard to read. It's trying to tell you of crankcase distortion, caused by alternation of extreme heat and cooling. And if you look at them as a group, this is the way bearings marked by crankshaft or crankcase distortion will look. It's best to always check the crankshaft alignment before replacing bearings. Now here's a common one. This bearing is yelling for oil. Simple, but completely fatal. Check the whole oil flow system to find plug passages, oil leaks, broken oil pump, blocked suction screen, or you may find the owner is your problem. But don't put in new bearings until you've caught the culprit. Now what does this bearing say? Well, everyone is to be congratulated. Just plain normal wear. The owner and the mechanics have kept this car in top-notch shape for 150,000 miles. Everything on it, but the reputation, has worn thin, so that when it goes, it will probably disintegrate all at once into thin air. Meanwhile, check all friction points in the engine, because each will have been subjected to the same wear as the bearings. There we have an introduction to the detective work of bearing replacement. Now let's see how the theory works out in actual workbench practice. Believe it or not, the most important part of a bearing replacement job is cleanliness. Over half the failures are from dirt. You know the kind of minute tolerances we're talking about. They can be wiped out by dirt. Let's avoid that with clean tools, a clean bench, everything as clean as possible. For example, when the oil pan is removed to be cleaned, be careful that the open crankcase isn't subjected to blasts of dust. Then, right at the outset, check to see if the oil suction screen needs replacing. And before we get too deep into the work, let's talk for just a moment about parts identification. In some engines, the position of parts is identified by steel stamped numbers that appear on the valve or camshaft side of the engine. Mixed or reversed caps can cause misalignment and excessive bearing wear. When identification marks cannot be found, stamp or prick punch the parts yourself, so they'll be put back in the same position. Next, check the crankshaft for scored, out of round, or tapered journals. When any of these conditions are found, the shaft must be reground. For best results, grind against the engine shaft rotation toward the high tolerance, and polish the journals with the shaft rotation to a 20 micro-inch finish or better. Be sure the oil holes are blended into the journal surface. If regrinding is not required, record the largest diameters of main journals and crank pins. This is important. It will determine what bearing you select for proper oil clearance. After removing any crankshaft oil plugs, thoroughly clean all oil passages. Then check the connecting rods. The rod bearing bore and the piston pin bushing bore should be parallel within 1/1000th of an inch in 6 inches of pin length. If rods are not parallel, misalignment and bearing failure will result. Therefore, out-of-parallel rods should be replaced with new or reconditioned ones. The rod bore should be round within 1/1000th of an inch. Less roundness than that will reduce oil clearance at the parting line. The rod bore finish should be smooth enough to make good bearing contact and transfer heat away from the friction surface. Check your valve stems and guides. Heavy carbon below the head can mean worn valve guides. If any machining was done in the block, clean it meticulously. Don't forget to remove any chip prevention plugs in the oil holes. Swab and flush all oil passages. Air hose? Yes, but be careful you don't blow dirt in. Now, how to select your replacement bearings. If you have a choice, lean every time in favor of bearings equal to the quantity of original equipment. A special chapter on the important procedure of selecting undersizes is found in the Clevite Mechanics Engine Bearing Reference Manual. Compare to see if the old and the new are the same in all respects. If not, remember there may have been a design improvement. Check your parts distributor. Until you're ready, keep the bearings clean and don't touch the bearing surfaces if possible. So you don't undo your good work so far, double check for cleanliness in all your work areas. Then check your saddle bore finish for nicks and scratches. Clean and install the main bearings and crankshaft for an alignment check. If your shop uses the Prussian blue alignment method, be sure to keep the coating of blue ink very, very thin to prevent the ink from oozing onto parts not actually touched and misleading you. After torquing down the main bearing caps and rotating the shaft, remove the crank in this manner and examine it. 75% covered with blue is acceptable. 85% is excellent. Now check your bearing clearance. Put Plastigauge the length of the bearing insert or the journal. Be sure it won't be in the oil hole in the journal. Be sure the crankcase is upside down, so the weight of the crank won't influence your reading, unless you're making a frame overhaul, in which case relieve the weight of the crank with a jack. Measure at the widest point of Plastigauge and read it here. This works equally well on main or rod bearings. As long as you have the engine down, check the camshaft bearings. Use a diagonal bore gauge for size, roundness, and taper. Measure 3 diameters 120 degrees apart at the front and rear of each bore. Check your Clevite manual for tolerances, page 64. The cooling system passages, are they clean? Of course, the radiator should be checked before disassembly. Pistons. Clean them inside and out, including the grooves. Then decide whether they should be used or replaced. Also, check the vacuum booster pump, the oil filter, air filter, and crankcase ventilation. Before reassembly, check all parts for absolute cleanliness. Inspect all bearing caps and rods for any burrs or nicks that might interfere with bearing seating. Wipe off all bearing backs, crankcase, and rod bores. and seat of the bearing caps. Be sure that the oil holes in the bearing register with those in the bearing seat. Remember, do not file bearing parting faces for any reason whatsoever. The bearings as received are precise and need no further operations. What about shims? Well, only if the original manufacturer used shims. If so, be careful to duplicate exactly the original installation, noting whether the manufacturer's shim extended over the parting faces or just to them. Front and rear main bearing oil seals are an important part. Don't throw away a good job by brushing off this operation. A tight or poorly lubricated oil seal has often burned out an otherwise good bearing job. Be careful not to reverse upper and lower main bearing inserts. Coat the bearing surfaces and journals with heavy oil, but don't get any on the bearing backs. Use a torque wrench to draw up the bearing caps, and follow faithfully the recommended torque shown in the bearing shop manual. Use new bolts. On the main bearings, alternate your wrench from one bolt to the other instead of fully torquing one first. When lock nuts are used, get new ones and don't draw them up too tight. On end clearances, check your Clevite Mechanics Reference Manual, Section 8. To check end clearances, pry the crankshaft as far forward as possible and insert feelers between the front flange of the bearing and the mating surface of the crankshaft. Check both front and rear. What if the end play is greater than the book allows? Use a thrust main bearing with oversized flanges. With this bearing, you can machine the flange faces to obtain proper end play. Work toward the lower limit of end play tolerance. Double check to see that all the rods, main and rod caps did not get accidentally reversed during installation. Also check your connecting rod end clearance, though it should not change. Now for a final check on the entire job. Your oil pressure loss indicator has some advantages, though it's only for pressure lubed engines. This method checks the oil clearance, but it also shows up oil leaks. It pre-lubes the engine before it is turned over on its own power. A job well done? Yes, indeed, and why not? He's a factory-trained, highly experienced mechanic with a great deal of both theoretical and practical knowledge. But what he did here, you can do too, with a little study, a great deal of cleanliness, and lots of care. And these procedures can pay off for you with more customers and more satisfied customers. Automobile repair is a pressure business. When the customer's got troubles, he acts as if you had been driving his car. He wants it fixed in half the time at half the cost. But when you know your stuff, the customer somehow knows you know it. He doesn't talk, he listens. He brags about his mechanic like he does his doctor. Which is why, no matter where he's located or how he parts his hair, the automotive world will beat a path to the door of the man who's got his bearings.